This is still section 11.3. We are still working with the derivative. I want to review a couple things with you before we start. What is the derivative? It's the instantaneous rate of change. Nope, that's not the derivative. That's something else. It's the instantaneous rate of change. The derivative finds the instantaneous rate of change. It's also a formula for the slope at any point on the curve. You know you're right next to the video though. Okay. Point that out. So the derivative is the instantaneous rate of change. It's also the formula. This is informal. But it's the formula for the slope at any point on the curve. Keyword at any point, because if it's between 2 points, you're not using the derivative. How do we find the derivative? What is the formula?
F of x plus h.
I think you're starting off wrong.
Our limit of x is to, or h is 0.
Limit as h tends to 0.
And then it's f of x plus h minus f of x all the way.
Very good. And we need to evaluate. Just like we talked about Tuesday and yesterday, in order to evaluate and plug 0 in for h, you are going to have to simplify or use some manipulation techniques so that h will cancel out of the denominator. Okay? That's the formula for the derivative. I just wanted to summarize that with you. You're going to find the derivative of each equation. The first equation is f of x equals 4x squared minus 5x. I do not want you to use the shortcuts if you happen to be catching on to those from yesterday's stuff, but I want you to do this the long way. Okay, so f prime of x equals, I'll do the first one with you at least, probably both of these just for time's sake. F prime of x is going to equal the limit as h tends to 0, big fraction bar, subtraction sign in the top, and h in the denominator, and I usually put a set of parentheses after the fraction bar. Okay, now I talked to you yesterday that it sometimes is easier for people, instead of trying to go straight into this formula, sometimes it's easier to find the pieces first. The pieces we need are f of x and f of x plus h. Well, f of x is right here. What's f of x plus h going to equal? If that's f of x, what's f of x plus h? Try not to skip steps, just give it to me from the beginning.
You already know that you square in there. It's 4 times 2x. Is x squared equals 2x on the slope?
No. I don't want any shortcuts. Not today. I don't want any shortcuts for this. What I do want is, what is f of x plus h? What I'm asking. Okay, don't plug 0 in for h yet, because you'll get 0 in the denominator. So leave it as x plus h. Good going. Here, let's keep going. Minus 5 times. Good work. Took a little bit of time yesterday to get us back into the groove of function notation. You not being here yesterday, you did really well. Okay, so if I were to FOIL this out, we did that yesterday too. If I were to FOIL this out correctly, I would get x squared plus 2xh plus h squared times 4. is going to give me 4x squared plus 4xh, 8xh, thank you, because it's 2xh, it's 4 you multiply by 4, plus 4h squared minus 5x minus 5h. Don't worry, I'm going to rewrite that again, because that is what goes right here in the top part at the beginning before the subtraction sign in your fraction. So 4x squared plus 8xh. I still need more space. I even extended it and I still need more space. Not again. There we go. Okay. Plus 4h squared minus 5x minus 5h. That's f of x plus h minus f of x. What is f of x? I have to subtract that quantity, 4x squared minus 5x. I kept a set of parentheses because I'm going to distribute the negative in the second step. I don't ever do that in the first step, especially when I'm just getting used to these. Okay, so the limit as h tends to 0, and I emphasized this with you yesterday also, don't quit writing that limit until you take the limit by plugging 0 in for h. You've got to keep writing it. Okay? At this point, it's all about manipulating. So 4x squared plus 8xh minus 4h squared minus 5x minus 5h, and then I can distribute this negative. Minus 4x squared plus 5x. Very good. What can I do? Cancel stuff. What can I cancel? And 5x. Good work. Everything in the top that you are left with has what in it? An h. That's really, really important. If it doesn't have an h left, you probably did something wrong. Okay, so let's keep going. The limit as h tends to 0 of, take an h out of everything in the top, and I mentioned that to you yesterday that it's more foolproof to do it that way. Take an h out and you get 8x minus 4h minus 5. Very good. The h's cancel, and you are left with the limit as h tends to 0 of 8x minus 4h minus 5. You don't want to not write the h until you are plugging 0 in for h, which is now. Plug 0 in for h to evaluate all the h's. You get plug 0 in and you get 8x minus 5. This is f prime of x. Again, notice I quit writing the limit in the very last step. When I plugged 0 in for h is when I quit writing that limit. Okay? This is the derivative. That's what I asked you to find. Again, because of time, we're definitely going to do the next one together. So let's take a look at the next one. F of x equals the square root of x plus 1. And actually, I'm going to put this on another slide because we are going to use this one to do what I want to do with it. So f of x equals the square root of x plus 1 is outside of the square root. So there's more to this one. Use this equation to find f prime of x. We're still going to do that. Okay, so let's take the limit as h tends to 0, big fraction bar, subtraction sign in the top, h in the bottom. I need f of x. F of x always goes right here. Square root of x plus 1 in a set of parentheses after the subtraction sign. What goes before the subtraction sign? f of x plus h. F of x plus h is going to be what? Let's be very careful here. No. Yes, the square root of x plus h plus 1. Okay, because you replace the x's with x plus h's. Okay, so the square root of x plus h plus 1. Now this time I did, right? Huh. What happens?
Well, if you do, I cancel out the ones.
Well, I can distribute the negative and that'll cancel out the ones. Very good. So I'll get the limit as h tends to 0 of the square root of x plus h minus the square root of x all over h. You cannot simplify that no matter how creative you think you might be. But you can manipulate it.
By plugging 0 for h.
I can't plug 0 in for h yet.
H is on the bottom.
Because h is still on the bottom. Yeah. I would love to plug 0 in for h, but I can't.
Oh,
I need to manipulate this. What manipulation techniques do you have from Tuesday? Monday? Tuesday? Yeah, Tuesday. Factoring? Factoring by grouping and just factoring normally. And what other one? Maybe we should try that one here. Multiplying top and bottom by the conjugate. Of what? What is the conjugate?
The square root of x plus h plus the square root of x.
I didn't say it would be fun, and I didn't say it would be nice, although this is going to turn out pretty nicely once you're all said and done with it. Take that quantity in the top times x plus times the conjugate of the top, and take the bottom times the conjugate of the top, and you're multiplying by 1 and you're not changing the fraction. So this is the limit as h tends to 0 of, be careful, what do you get in the top? The bottom, I'm just going to recopy because I don't need to multiply it together unless absolutely necessary, and I won't know that until the next couple steps are done. So what's the top becoming?
4 square root.
X plus h.
Okay, yes, no, it's not, it's square root of x plus h squared, which is what?
X plus h.
X plus h. Yeah, if you take a square root times itself, you just get what's underneath. So firsts are giving me x plus h. The outers and the inners are going to cancel out. And the lasts are going to multiply to be what?
Negative x.
Negative x.
H over.
Ah, and who's throwing a party? Okay.
And then 1 over.
I would be like, yes. H is there. H is going to cancel. I'm happy. It worked. Limit as h tends to 0. Oh.
So it'd be
1
I'm going to take an extra step here, even though I don't normally do that.
1
1 over.
square root of x plus h plus square root of x.
Exactly. And now you can plug that 0 in for h,
So you get the square root of x plus the square root of x.
which gives me a derivative f prime of x
is 1 over.
Equal
square root,
to
2 times square root of x.
1 over the square root of x plus the square root of x, which is 1 over 2 square roots of x. I completely agree with you.
My leg.
That's the derivative form. That's the derivative. It's the formula for the slope. Find f prime of 3.
2 times square root of 3.
Okay, very good. 1 over 2 times the square root of 3. You just plug 3 in. Not nice? I didn't say it would be nice. I don't care if you leave it like that. If you wanted to rationalize the denominator, you can. You'll get the square root of 3 over 2 times 3, which is 6. If you want to rationalize the denominator, you can. I don't care which format you use. You're okay with this one right here. Okay? So I should put an or here. Because I don't care which of those you have. Now for the fun part. This is where the majority of our time today is going to be spent. Write the equation of the line tangent to the graph of f of x at x equals 3. What do I need in order to write the equation of a line? The slope and a point, x and y. The equation of a line can be written in two forms that you are familiar with. You can either go y equals mx plus b, or, and this is the one I would prefer you get used to, you can use y minus y1 equals m times the quantity x minus x1. It's point slope. This is slope intercept. Doesn't matter what it's called as much as it matters what you do with it. Okay? This is the one that I would like to use with you every example today. If you really want to use slope intercept, I'll help you with that. But it takes longer in general, and if it's not specified, use slope intercept. There's no reason to start there. Okay? Unless you're given the y-intercept, you don't need to start there. So I need a slope and a point. The slope, m, which is what? Good. Now I have 1 over 2 square roots of 3, or square root of 3 over 6. Either format, I don't care which. I need a point. Do I have a point? I have an x value. How do I find the y value? Plug 3 in where?
Your slope intercept form, or your
Point
slope form. You
Plug 3. Where do I plug 3 in to find its y value?
The x,
In
the equation, which, like,
that one?
no.
I already did that.
Right there.
No,
Wait,
I
you
need to
already
plug it in
have-
there too.
already found it.
It's simply.
I don't have its y value. I need a x and a y.
Yeah, it's where you find it.
I don't, the y value, it comes from f of x. Y.
So it's the square root of 3 plus 1.
So square root of 3 plus 1. Ladies and gentlemen, if you need the y value, you evaluate that x value in f, in the original function. So we need to plug the x value into both the original and the derivative. The original to find its y value and the derivative to find the slope. That's how you write the equation of the tangent line. Okay, so f of 3 is going to equal square root of 3 plus 1. Is that correct? Okay. So the square root of 3 plus 1 goes right there. Now let's use the point slope form of a line. Now write the equation of the line. Y minus blank equals blank times x minus blank. What goes where? Where does this go? M. So 1 over 2 square roots of 3, or square root of 3 over 6. Where does this go? Good. So I'm going to put 3 here, and I'm going to put the square root of 3 plus 1 here. What's wrong with how I have this written down? I have to subtract all of the y value and all of the x value, and this y value is a binomial. So I need a set of parentheses. I have to subtract all of it. I could subtract it square root of 3 minus 1. That would be fine. Okay? And I'm okay if you leave it like that. We're going to do the equation of the tangent line some more. What's the longest part of this process?
Find the slope.
Finding the slope. Finding the derivative. So guess what? There are some shortcuts to find the derivative, and we'll teach you those next year. Okay?
Next year, right? Sure.
Because of time. Okay, on this one. F of x equals x squared minus 1. I'm also going to give you the point 2, 3. I want to know the slope at 2, 3. So first of all, I need f prime of x. It's not 2x minus 1, it's just 2x.
Oh, yeah.
Okay, we did it yesterday a bunch, and because of time, I'm actually going to allow you to jump straight there because our focus for today is writing the equation of the tangent line, not finding the derivative. You need the derivative to do it, but the focus is what do I do with it, not how do I find it. Okay, so f prime of x is 2x. F prime at my point is going to be my slope, and actually let me write it that way. M equals f prime at my point, which is 2. Write that down. You can even put a star by it. Okay? The slope is the derivative at your point. So now we're going to take 2 times 2, which is 4. That's the slope at 2, 3.
And now we have a point too.
Oh, good. So now let's write the equation of the line tangent at 2, 3. I didn't want to move it down quite that far. There we go. So the formula is y minus blank equals blank times x minus blank. What goes where? Very good. The 4 goes before the x quantity. Where does 2, 3 go? X1, Y1, and don't forget to put X with X and Y with Y. I've had people start to mix those up now, and you can stop there.
Or you
Yes,
could-
ma'am.
For the f prime of x equals 2x, you just gave that to us, right?
I did.
Okay, I was just making sure.
We
you
did it yesterday,
Right, the one
actually,
that
and so that's why I just jumped straight there with it.
That's
Because
fine.
he brought it up, and I was like, yep, we did it yesterday, and we're already kind of short on time, so I
Alright,
want to make
that's
sure
fine. I
that
was
we
just
get
making sure.
to this.
But,
Okay?
Ms. Eckhoff, what if the actual equation be y equals 4x minus 5?
Nope, you can leave it like this. I'll accept either, but I'm just telling you that if you try to solve for y and make a mistake, you're gonna lose points, where on this one you wouldn't. Let me say that again. If you have this equation written down, and then you try to solve for y and make a mistake in solving for y, you're gonna lose a point. Okay? So I say quit while you're ahead. If it doesn't specify, write the slope-intercept form, or it's not a multiple choice and the multiple choice question where you're trying to match a slope-intercept form equation, don't put it in slope-intercept form. You just need a relationship between x and y. Does that make sense?
Yeah, I guess so. But you actually right now the equation.
I know.
Just gave that to us.
What happened?
It's already up.
We'll talk. Okay, Desmos is what I want to use right now.
That's all.
What is?
Just the keyboard pops up.
Start graphing. I want to graph the original, which is y equals x squared minus 1. X squared minus 1. And I want to graph the derivative equation, which is
Y minus 3.
y minus 3, and I love Desmos for this, it'll handle this, equals
Yep. 4 times x minus 2.
4 times the quantity, x minus 2. Done. Let me turn this darker so that you can see it. There you go. Does it look like the graph in red has a tangent line in blue, which is tangent at the point 2, 3?
Yep.
2, 3 is marked. They think it's important. I think it's important. Does it look like the blue line is tangent to the red line?
Yep.
I think you did it right. Okay? That's cool. It is, it's cool. So we can do that. I think it's fun. You guys may not think it's as fun, but I think it's fun. Last thing I want to do with you today is find the points where the tangent line is horizontal. What does that mean?
Where it's y equals a certain number.
No.
Or
For a line to be horizontal, it's y equals a number for the equation. What does that tell me about anything else?
It has no slope.
Has no slope. Assign a value to that.
also
Zero.
therefore,
Zero slope.
therefore you can't have a
So you know that, hang on, yes you can, hang on. You know that m equals 0. What does that, how does that relate to the derivative? There you go, the derivative equals 0. F prime of x equals 0 is where the tangent line is horizontal. That's what tangent line horizontal means. So now I'm going to give you an equation. F of x equals x to the fourth minus 2x squared, and for this purpose, I'm also going to give you the derivative. F prime of x equals 4x cubed minus 4x. So I'm giving you those two things. I want to know all the points where the tangent line is horizontal. I need f prime to equal 0. So I take f prime of x and set it equal to 0. 0 equals 4x cubed minus 4x. Can you solve that?
take an x out of
Take an x out. Take a 4x out too if you want. Doesn't matter. Take an x out. That's an excellent idea. In fact, excellent idea.
You're so funny.
X squared minus 1. Keep factoring.
x minus 1, x plus 1.
Yeah. A lot of times people forget that keeps factoring, and you can actually do it with square roots, but it's much more foolproof because people forget the plus and minus if they do square roots. It's more foolproof if you keep factoring until you can't factor anymore. Bless you.
Thanks.
So 4x equals 0 gives me x equals 0. X minus 1 equals 0 gives me x equals positive 1. And x plus 1 equals 0 gives me x equals negative 1.
Oh, there's
All
3
three
answers.
of those points.
Whoa, I need points.
There's
Those are all x's.
You just plug each one back in the original equation.
Plug each one back into the original equation. Awesome. I need an ordered pair at each of these. I know that I have 0, 1, and negative 1 for x values. To find their y values, plug them back into the original.
So
F of
0,
x.
0.
See? I highlighted points. Now I'm highlighting that you need the original, and now we're going to find the original value. My original was x to the fourth
Minus 2x squared.
minus 2x squared. So f of 0 is going to be 0 to the fourth minus 2 times 0 squared, which is 0.
The next one's -1.
F of 1 is going to be 1 to the fourth minus 2 times 1 squared,
1 minus 2.
which is 1 minus 2, which is negative 1. And this one, f of negative 1, gives me, careful, you have to raise the negative to the fourth also, minus 2 times negative 1 quantity squared.
Also, still the -1.
So it's still going to be negative 1, yes.
I messed up the negative. So I need to keep it.
To write the equation of the tangent line, find the derivative, evaluate the derivative at the x value, and write the equation using the xy value and slope. To find where the tangent line is horizontal, set the derivative equal to 0 and solve. Got it? Big stuff for today. Problems for you to try.
So, after going over the review,
Yep.
do I have to be
Probably you'd be okay. It's up to you. It's kind of a longer lesson. 45 minutes. Page 809, I want you to do numbers 42, 44, 46. This is due Tuesday, because we're not in school, you don't have, that's the second time you have this class after today. That's what I'm trying to say. And I also want you to do 51.
What was yesterday's? I was chopping.
What is the circuit in the field
Do they have ABC?
until
Okay, end of the video.